So in this session, we'll discuss the doubts related to the Newton's law. The first one is on page number 7. Page 5 first, question 14. So in this question, Einstein imagined a person in a large box without a window. He suggested that no way to see outside. The person could not tell whether he was experiencing the gravity of the earth or whether he is in a deep space, which is having an acceleration of 9.81. So about the Einstein account for Einstein's suggestion by explain each case whether a person standing in the box would feel their feet, and you may help assume a person of mass m. So what will happen, because the one who's there in a deep space, he's accelerating and his acceleration is same as the gravity, and another person is stationary. So the person, first thing, when we compare the resultant force, when a person is stationary, there is no resultant force. And when the person is accelerating, there will be a resultant force. So stationary on Earth will not experience no resultant force on this person, whereas there will be a resultant force on another person who's accelerating and having acceleration of 9.8. The weight of the person will act downward, so there will be a normal contact force upward. So weight which is acting downward for the person experience an upward force from the floor, the normal contact force, but the resultant force will be 0. What about the second person? Because he's accelerating, so resultant force should be equal to ma, and the acceleration is equal to gravity. So we can say that resultant force is equals to m and acceleration is due to gravity is equals to mg. And what is mg? Mg is equals to weight, so we can say resultant force should be equal to weight. So the force which is accelerating this person, that is equals to weight of the person. And in both cases, the person feel the force from the floor. The first one, it will experience a normal contact force, and the second one, there will be a force to produce an acceleration or to create a resultant force. Next is page 7, question 19a. So page number 7, question 19a2. 19a2. The maximum frictional force between the lorry and the box is 630. Explain why they limit the maximum acceleration. So the frictional force is a force which is opposing the motion. So, and the acceleration of the box should be equal to acceleration of the lorry. That's why it will remain on the lorry. Otherwise, if their accelerations are different, then the lorry will means the box will slide down. So if this is the direction of the motion, the friction will try to oppose. What will be the natural tendency of this object? Because of its inertia, it will try to resist the change in state. So friction will try to oppose this box to slide down. So the maximum value of the friction is 630. So frictional force is equals to ma, the maximum force. The frictional force is basically, that is the resultant force which is causing an acceleration. So resultant force is equals to ma. So 630 is equals to mass of the box is 200 and acceleration is a. So it will be 630 divided by 200. So 630 divided by 200, this will give the maximum acceleration which this box can have. So it will be about 3.15 meter per second square. This is a maximum acceleration. If it is more than, if acceleration of the lorry is more than 3.15, then this box will not remain on the lorry. This box will slide down or it will skid down. Is it clear? Because the acceleration of the lorry is same as acceleration of the box. So maximum acceleration which the box can have, that maximum is 3.15. So that's why they're saying why it limit the acceleration of a lorry. Like if the lorry acceleration is more than 3.15, then this box will slide down. Next page number 19. Page number 19, question number 18a. Complete the diagram to show the airflow. So this is about the laminar and turbulent flow. In order to fly higher, the bird can tilt the wing more, and if it tilts them too much, the diagram shows the airflow above the wing become turbulent. So above the wing become turbulent, complete a diagram to show how airflow around the. So if this is the direction of the flight, the direction of the airflow will be opposite, and it became turbulent. So how we represent turbulent flow? That there will be a sudden change in the direction from the top. So that's how we represent a turbulent flow. This is page 19 and then page 22. With reference to Newton law, explain how the downward force from the leg enable the bird to take off. So basically what happened is, for the bird, when it is in contact with the ground, so this part, when it is in contact with the ground, the weight of the bird which is acting downward, and the normal contact force is acting upward. So weight is downward and normal contact force R is upward at this point. And when we compare with reference to Earth, if there is a bird which is on the surface, so Earth is pulling the bird is also pulling the Earth. Now as the bird pushes the ground, so the force increases. This is the bird. So there is a greater downward force. Like if I say the weight of the bird is say 0.6 Newton, the normal contact force was also 0.6, and the weight is 0.6 Newton, and the gravitational pull of the bird on the earth or earth on the bird, that is 0.6. So both forces are balanced. But now what happened? There's a greater downward force. So weight is there and there's an extra downward force. So as a result, what happened? The downward force increases. The downward force is about like 2.1, 2, 3, 4, 5 is there. So 2.04. So if the downward force is 2.04 Newton, then the upward force, the normal contact force, will not remain 0.6. It will also increase to 2.4 to balance it. So 2.04 Newton will be there, the upward 2.0 weight is there, and then the push of the bird on the ground. So as a result, what happened? Greater downward force, more upward force will be there. And when we check here, this example, the weight is downward, but there's an upward force from the surface, which is 2.04. As a result, there will be an upward acceleration. That's how the bird is able to lift off from the ground. Is it clear? Then this was page number 22. C2 is also there. So use the graph to calculate the maximum acceleration. How we can calculate the maximum acceleration? The weight of the bird is acting downward and there is an upward force. The difference of the two forces will give us the resultant force. So how we can work out the two forces? So the weight, when it is standing still, this value is the weight of the bird. So it is 0.64 or 0.62. It is between 0.62 is the weight of the bird. And then the upward force, the normal contact force or the upward force is 2.06. So to calculate the resultant force, that will be the difference. So 2.06 minus 0. The mass is there, but we can use that 0.64, so or 0.62. So when we subtract, this will give us the resultant force, because weight is acting downward, normal contact force is acting upward. So weight is there, R is there, so R is 2.06 and weight is there 0.62. So difference R minus W is equals to MA. So R minus W 2.06 minus 0.62. The mass of the bird is there, which is given in the beginning of the question, that the bird has a mass of 0.063. So mass is 0.063. So it will be A. And when we substitute, we'll get the acceleration of this bird. Next is question 20, page 27. Carrying out uh, carrying out the stack coin experiment, the students sometimes observed that the flick coin did not stop, but it changes the direction. Like instead of being stopped, what happened when the flick coin is hitting, it changes the direction. So what could be the reason? Basically, the change in the direction is the point where it experiences the force. So example, if these are the two coins, okay, and this is a stack, because you're looking from the top, this is a stack and this is a flick coin. So when we hit this flick coin, what happened as it is moving, when it will come in contact, it will exert a force, and as a result, the same direction force it will experience. So the net force, the resultant force on the flick coin will be there, and that cause a deceleration. So the flick coin will decelerate or it will slow down. But what will happen if it is not colliding, like if it is making certain angle here? So as a result, when it is making certain angle, this is the direction in which the flick coin is moving. But when this flick coin will come closer and it will collide, so there will be a force exerted by the flick coin on the stack, and the stack will also apply equal force in opposite direction. So what this force is not like originally the direction of the motion and the force are opposite. That's why it was decelerating. But now what happened? The direction of the motion and the force with the flick coin experience, they are not opposite of each other. There is an angle, certain angle between them. So due to this angle, what we'll observe? We'll observe this flick coin will changes the direction. Is it clear why the flick coin changes the direction in some cases? Next is page number 29. 29 part 18D. The maximum reaction force was reached at time is equals to 0.9. Calculate the acceleration of an athlete at this point. So to work out the acceleration, the maximum reaction time of a force when t is equals to 0.9. So this is the same way like we calculated the acceleration for the upward acceleration for the bird, the same way we'll calculate. So initially when a person is standing, his weight is acting downward. So downward is a weight and normal contact force is there. But when he's pushing the ground, greater downward force, so more upward force is there. And that upward force is more than the weight. That's why it is producing an acceleration. So what is the weight? This value is representing a weight like 500, 600, 700, and this is 750. So weight of the person is 750. And when he pushes the ground, the maximum upward force the ground is applying is about 2450. Each is representing 100, so it is 2450. So this value is 2450 newton, and this is 750. So what we will do, there's an upward force 2450 newton, and there's a downward force 750 newton. So we'll take a difference. So 2450 minus 750, that will give us a resultant force. And after knowing the resultant force, we'll use the formula F is equals to ma. The resultant force is there, m is there. So we'll have the acceleration of this person. Is it clear? Then next question is from page number 31. This was 29, 31. The passenger in the train, a passenger is standing in a train. The train is accelerating and he falls backward. This is the direction of the train, but he is falling backward. Use the Newton's first law of motion. Explain why he falls backward. So what is the reason why he falls backward? The first law is about the inertia, because what happened? Inertia means tendency of an object to resist the change in state. So when the object will try to resist the change in state, it will. So Newton's first law of motion. So according to Newton's first law of motion, an object at rest or move with constant speed until unbalanced force act on it. So if there is an unbalanced force, there is a force which is not balanced. If that force is acting on the object will accelerate, otherwise it won't accelerate. So the train is accelerating, but the man originally was at rest. So that's why the man resists the change in state. And when he resists the change in state, he tend to fall backward. Or you can also say the acceleration of the man is not same as acceleration of the train. That is why he also fall backward. Like he's resisting the change in state. And for part B, as a train leaves the next station, the passenger hold a vertical support that prevent the passenger from falling back. With reference to laws of motion, explain why holding a vertical support prevent. So if one thing, if the train is accelerating, if there is an acceleration of a train, it means there will be acceleration of the person as well. Like train is accelerating, the person should also accelerate. But how the person will accelerate? So there should be a resultant force act on the person, which cause the person to accelerate. So as the man is moving backward, according to Newton's third law, like if there's an action force, there will be equal reaction force but in opposite direction. So as the man is holding this support, so men tend to lean backward, like men tend to move backward. As a result, the pole will apply a forward force, try to balance it. So the man pulls backward on the support, and according to Newton's third law, the support will exert opposite force on the man, and this force is a resultant or unbalanced force. There should be an unbalanced force. Why? Because a person is inside the train, and when the person is inside the train and train is accelerating. So if train is accelerating, it means the man should also accelerate. So this force causes the acceleration of the man, and the acceleration of the man is same as acceleration of the train. Even though the man inside the train, the man is not moving. But because the train is moving, so the acceleration of the man should be equal to acceleration of the train. So according to Newton's second law, the third law, action and reaction forces, like there's a pull of the support, like man is pulling the support will pull the man. And that Newton pair forces will create a resultant force on the man, and that resultant force will cause the acceleration, which is equal to acceleration of the train. Is it clear, this question? So the points which you should mention here, so the man is pulling the support, the support will pull the man, and then what, how we know whether there's a resultant force or no? If the same question was there, they mentioned the direction of motion, but they said it was moving at a constant speed. So if the object is moving at a constant speed, in that case, what happened? There should be no resultant force. But because in the question they mentioned the object is accelerating, there's a direction of acceleration. So men pull the support will pull the men, and it will produce resultant force on the men. And you have to mention here, like men pull the support will pull the man. That is according to Newton, third law. And produce a resultant force and create an acceleration. So produce resultant force on the man, and that resultant force will cause acceleration, and the acceleration of the man should be equal to acceleration of the train. So whenever even you, if you're inside the bus and the bus is accelerating, it means the acceleration of a bus is same as acceleration of you inside the bus. If you are not having the same acceleration, then what will happen? Either you will fall backward or forward depending on what is happening to the bus. So this was page 31, 32, and then 34 question, page 34, question 30. Okay, in this question, a student has two magnets A and B. A magnet A is smaller and weaker than magnet B. The weight of magnet A is determined using a digital spring balance and the weight of the magnet B using a top bend balance. When a magnet A is moved to a position just above magnet B, there is an attractive force. The two magnets attract each other and the reading on the balance changes. So what happened? How the reading of the balance change? Look, weight is acting downward. For magnet A, weight is acting downward and the attractive force is also acting downward. It will pull because opposite, unlike poles of the magnet attract. So here in the beginning only weight was acting, but now weight and the attractive force are there, so the reading on this balance will increase, the digital spring balance. And what about top pen balance? The weight is acting downward, but there's a attractive force from the other magnet which is in opposite direction upward. So as a result, what happened? The reading on the top pen balance will decrease because initially both weights were downward, but now when we bring the two magnets closer to each other, one will attract the other one, means one is experiencing attractive force which is directed downward, so there's a greater resultant force. That's why the reading on the digital spring balance will increase, and the reading on the top band balance will decrease. Is it clear? So you will mention according to Newton, and whenever a static question is there, you should always use certain terminologies like resultant force, Newton laws. So according to Newton third law, the two magnets will attract force on each other but in opposite direction, and that create a resultant force on magnet A and B. The resultant force on magnet A will increase as the attractive force and weight are acting downward, so reading will increase, whereas for magnet B the resultant force will decrease because the weight and attractive force are in opposite direction. So this was exercise related to the deep space question. The man is in a deep accelerating, so due to the third law there. Now in in the deep space question, look, the third law, if there is a downward force, there should be an upward force. But because in a deep space, there is no gravity to pull the object downward. If there is no gravity to, like, here what the two difference between the two is that here the gravitational force is there which is pulling the man, and due to gravitational force there is a downward force. So if there is a downward force, there should be an upward force. So downward force equal to upward force. But here what happened, as I mentioned, deep space, there is no effect of the gravity, so there is no downward force. The only force is there which is causing the acceleration, and that force is equals to ma. And acceleration is equals to 9.8 or g, so that force is equals to mg, or mg is equals to weight. So the force which is accelerating a person is equals to weight of the equal to weight of the person. It's not like the weight is not there in this deep space, so there is no downward force. So only what happened, there is a resultant force on the person, there is a resultant force on this box which is causing the acceleration. Yeah, so that contact force, whenever object are in contact, the vertical force is there. That is a contact force. So this contact force is actually a resultant force. So this contact force will be equal to weight, or it is equals to resultant. But here what happened? The weight is acting downward, the contact force is acting up. So contact force minus weight is equals to 0, because both forces are balanced. But here the force is a contact force, and that is causing the acceleration 9.81. Is it clear now? So this was exercise related, the doubt related to topic Newton law of motion. Any other question related to this topic? Any question or a doubt? So I'll end the session and share this with you.